And this is lesson 15 of CCNA course, and we will talk about RSTP, EtherChannel, PortFast, and BPDU Guard, all review from cybersecurity vision. Well, we have already talked about the BPDU Guard option and how to configure that. But here I will explain more fully, and in the next video we will have a very comprehensive lab about switching, and we will examine all switching technologies from VLAN to BPDU in a complete lab at once. Now let's go to this issue. If you remember, we said that STP was started automatically between the switches to prevent loops in the network. Well, a switch was chosen as the root switch, and the status of that of all ports between on all switches was determined accordingly. Now, if the root switch was changed for some reason, the port that was blocked in order to prevent the loop would be changed, and another port would be blocked. Okay, this table shows the difference between STP port states versus RSTP port states, and discuss about this. But what is RSTP? RSTP is rapid spanning tree. It is the fastest spanning tree, or faster than the STP. If you shut down the port by manually by shutdown command in STP state, the port will shown as disabled, and in RSTP shown as disabled as well. If the port function or port status ignore incoming data and not used, in STP state will shown as blocking, and in RSTP shown as discarding. If it is in interim state without MAC learning and forwarding, but not disable or block. Interim state without MAC learning, not listening. Without MAC learning and forwarding, in STP state shown as listening, and RSTP doesn't have like this item. And if port status is an interim state with MAC learning and MAC or data forwarding, MAC forwarding, it is means learning in STP, and in RSTP shown as learning as well. And in a stable state with MAC learning and data forwarding, in STP forwarding, and in RSTP shown as forwarding. Now this is our network. Imagine we have SW1, SW2, 3, 4, one computer connected to SW2, and one hub switch connected to SW4. If we run the STP between the switches, if we have the RSTP, the connection between two switches known as point-to-point. These are the port status when we have or when we started the RSTP. And if we connected, if we have a network connected from SW4 or from the switch to the hub, to the another device which is hub switch, it's known as shared port. And we have if we have connected the computer to the switch, it's known as point-to-point edge port, because it is the end of the network, it is the edge, and the network will not continue after this. But the main question is why we need multiple spanning tree, and the response is VLANs. Maybe you need to have some VLANs, for example, one VLAN for sales department, one VLAN for human resources department, one VLAN for finance department, and so on. And maybe you need put some switches based on each department, based on each floor, and configure many VLANs between the switches. And maybe based on your security policy, based on your networking needed configuration, maybe need one switch in one department to be a root switch, and that switch in another VLAN for another department. It's maybe it is not required to be a root switch, and another switch will require to be a root. So if you have multiple VLANs, the result is maybe you need per VLAN one switch, for example, be a root, and per another VLAN another switch may be a root. But the STP is a standard protocol for spanning tree performing that's known as standard 802.1d, and after that the Cisco created Cisco proprietary STP protocol or per VLAN spanning tree that's known as per VLAN spanning tree plus or PVST plus. Again, after implementing and introducing RSTP or 802.1w protocol in 2001, Cisco created another proprietary protocol that's known as Rapid Per VLAN Spanning Tree Plus or RPVST Plus. Sorry. Okay. So this table show about these protocols. STP, it is STP based, and number of trees for preventing loop between the switches. It is just one tree and known as known under standard 802.1d. Per VLAN spanning tree plus or PVST plus is categorized under STP and one per VLAN, number of trees per VLAN 1, and 802.1d protocol. If we perform and implement RSTP, it's categorized under RSTP and number of trees just one, categorized under 802.1w protocol. If we have RSTP, RPVST plus, Rapid PVST plus, it is categorized under RSTP per VLAN. If you have, for example, 5 VLAN, you have 5 separate anti-loop RPVST plus implementation, and maybe you have 5 different root switches, and 802.1w and multiple spanning tree or MSTP that allows the definition of many instances, for example, multiple spanning tree instance that chosen by the network designer, but not required one per VLAN. Definitely maybe one or maybe more than one, and categorized under newest protocol 802.1s. But before I go into the next slide, let me describe more a little. RSTP create one tree. Remind, RSTP create one tree. It's known as CST or common spanning tree. And while RPVST plus create one tree for each and every VLAN we have. RSTP, another important item is RSTP sends one RSTP message or BPDUs, hello BPDUs in network. It doesn't matter how many number of VLANs present, while RPVST plus sends one set of message per VLAN. RSTP and RPVST plus rapid per VLAN spanning tree plus use different destination MAC address for sending hello BPDUs. One of them is both of them are multicast address. One of them is multicast address that started with 0180, and another is started by 0100. And when we have transmission message on VLAN trunk, RSTP send message in native VLAN, but RPVST plus send each VLAN's message inside its VLAN's ID. Another item is EtherChannel. What is that? EtherChannel means you have you configured more than one physical port between two switches or between some switches, up to 8, and use all of them as a one single port. But what is the EtherChannel benefits? If you some switches with more than one physical port, and categorize all as a one single port and known as one number, or known as one group, all ports known as one group, for example channel group 1, channel group 2, or any numbers. It has some benefits. For example, first is redundancy between switches links. If you have just one port between two switches, and if that port fails, the connection will be lost and disconnected, and the transfer between the switches will fails. But if you have more than one physical port and all ports connected as one single port, it will provide redundancy, and if one link fails, another present link will remain the connection between these two switches. The second benefit is increased bandwidth. If you have connected more than one port between two switches as a single port, all bandwidth for all ports will be summed and will be provide more bandwidth for sending traffic between them. And the third item in benefits is lowest opportunity of STP change. Just if you have just one port between two switches and it fails, the STP configuration will be changed. Maybe a root switch change, maybe block port will change, and any other issue in STP. But if you have more than one port, the STP's opportunity for changing port will be lowest, because another port will remain the connection between switches. Okay, and what about the PortFast? What is the PortFast? This feature should only be configured on ports that are connected to the end user devices. For example, if you have connected one computer to one of the ports on SW2, you can configure that port as PortFast. And what does it do? I want to say simply, first it activates the port very quickly and then proceeds to learn the MAC address connected to that port. And what is benefits? Lower time change from blocking to forward, most appropriate for end user devices, and RSTP includes PortFast as well. And the last item in this video is BPDU Guard. The BPDU Guard feature is to prevent unwanted BPDU message from being sent by potential hackers who have gained access to the network, which I explained how to configure in previous videos. Now let's see what happens if such a scenario happens and BPDU Guard is not configured. Imagine that we have a network in which the server is connected to SW1, and the path of sending data from the GNAS computer to SW2 and SW1 and the server. Well, the established STP protocol blocks the communication between SW2 and SW3. Now, imagine a hacker may gain access to switch 3 or to switch SW3. This is the path for sending data. Imagine a hacker connected to SW3, but the security settings made on the switch have prevented the hacker from controlling it. But he was able to connect to one of the ports, and now the system may configure itself as a BPDU issuer, as a switch, in effect as a root switch, to change the data transfer path, and for this reason maybe perform maybe perform an attack and copy data or access to the data, and after that send to SW1. If we don't have BPDU Guard, maybe happens like this occurs. So to prevent this from happening, we must enable the BPDU Guard ability on the end user ports in the switch to prevent such incidents. Well, I have explained the concept so far. All the next video will be dedicated to a very comprehensive lab, so that we can practice all the teaching related to switching from the start, from the basic concepts to the setup of VLAN, STP, RSTP, BPDU Guard, and the rest. So don't forget and don't miss the next video. Thank you guys for watching video. Let's go to the next one and have a nice time.